One thing you should know about electromagnetic radiation is that it exists in a spectrum, with varying wavelengths and frequencies. Even visible light exists in different colors, because different colored light has a different wavelength and frequency. For example, sunsets are red because red has the lowest color wavelength, and red light is scattered the least when the sun is lower down from the Earth's perspective and light travels through more of the atmosphere, whereas in the day, light travels through a thinner portion of the atmosphere, so the scattering is less prominent. This is also why if you were to move a thermometer around a set of lights dispersed by a prism, you would get an increased reading if you went past red, as the light is sectioned into different wavelengths, and the infrared is present as a particularly low wavelength section. Infrared happens the most similar frequency to heat, which explains this. Grow up, guys. This is why night vision goggles survey infrared, which also happens to display one's body heat. This doesn't mean infrared and heat are the same thing. You may be wondering why low wavelength waves like ultraviolet, X-rays and gamma rays have more trouble passing through the atmosphere than larger wavelength waves, if they are smaller, and should have less trouble penetrating the atmosphere, if they are smaller. Because ultraviolet and such has a higher frequency, it has more energy. Ozone is unstable and needs a lot of energy to decompose to more stable oxygen, and won't bother absorbing as much radiation such as infrared as it doesn't have enough, whereas it will readily absorb ultraviolet. You might also be wondering why light shiny thermal blankets are used instead of black ones, when black absorbs more heat and light, especially when the blankets are used to treat things like hypothermia. There will be very little heat incoming in such a cold environment, so all heat is internal. A black blanket will internally absorb heat, which then gets heavily outwardly radiated when the heat passes to the outer side of the blanket. Black surfaces not only absorb more, but outwardly radiate more too. A light shiny blanket will reflect the heat back to the frosty guy internally. This is why igloos actually work. Last time I checked, igloos were why. They also work because their spherical shape means the surface area to volume ratio is low, so less heat can escape as there is less exposed surface. Metals are great conductors of heat because they have free electrons which can move around in what is known as a sea of electrons. This allows the metal atoms to easily move around and be spaced more compactly, making them more dense. Because they are more dense, there are metal atoms close together, which can easily move around and vibrate to pass on heat. The reason why evaporation has a cooling effect is because evaporation needs additional heat as well as that needed to raise a liquid's temperature, so will take this heat from its surroundings in some cases. Condensing will give out heat for the same reason. Less dense materials tend to be better insulators for this reason, which includes materials like wool and polystyrene. A thermos is also a great insulator because its capsule shape has a very low surface area to volume ratio. Why do different substances have different specific heat capacities? Before we start, the specific heat is the energy needed to heat 1 gram of a substance by 1 degree. Since it is always 1 gram, it doesn't have anything to do with accelerating the weight of the molecule, as it is the same overall in each case. Instead, smaller molecules such as hydrogen and helium are separate in a fixed mass, so repel each other more than a large molecule, where most of the mass is concentrated in molecules, so the atoms individually don't repel each other. Because the molecules repel each other more, their movement is restricted because they're always bumping into each other, so more heat is needed to overcome this. You may also be wondering where kinetic energy goes after one moves around. Well, some of the kinetic energy produced by muscles heats your body up instead of moving you around, some is lost by heat to the surroundings, such as air as you displace it, but this tends to be negligible at low speeds, although you do see stuff like meteorites and stuff falling from the sky on fire, because it moves so fast that it heats the air around it up that much. In actual fact, the kinetic energy when one is running gets transferred to the ground. Funnily enough, when you push against the ground you supply it energy, and it pushes you right back as a reaction, although we'll save that for P2. However, the process isn't efficient due to losses like body heat, heat to the air and ground, and sound, So although the Earth pushes you along, you will still need kinetic energy to keep going, and will eventually tire. This is why you can't run forever, because you lose a lot of the kinetic energy you could have been supplying to the ground, so not all of it pushes you back. When you stop, the energy gets transferred to the ground and doesn't get transferred back. Technically, due to conservation of energy, the Earth moves a super small amount when you push it, but not really since it's so tiny due to the size of the Earth. Although this is why quicksand works, because when your body pushes it down, it can't exert a big enough force back, so instead it sinks with you. Sad times. What goes up must come down. The reason gravitational potential energy has the word potential in it, is because when something moves up, it must come down, and will regain energy when it descends. When something gains GPE, it loses kinetic energy because it is using it to move against gravity or the Earth's core pulling it down. Similarly, kinetic energy is gained when an object descends because gravity and the Earth's core is pulling it down and doing work on it. Both nuclear fission and fusion release loads of energy. Don't worry about them too much, they are more complicated than breaking and forming bonds, but they do both release energy. Solar panels are not very efficient simply because all of the sun's radiation is not visible light. As you know in P2, voltage over current is resistance, which means voltage over resistance is current. Across a long-distance cable such as those found in pylons, there will naturally be more resistance, which is why the voltage is stepped up to maintain a current. However, because voltage times current is power, the voltage must be stepped down when electricity reaches homes, or else overpowering is a risk. As you already know, all electromagnetic waves have the same speed, so theoretically have the same energy. However, because they have the same energy, waves with higher frequencies and lower wavelengths or sizes are far more concentrated than vice versa, hence they are known to have higher energies. You may also be wondering why exactly refraction happens. You should first take into account that light shown on a surface at a right angle to it, is reflected right back where it came from, and doesn't feature a change in direction, whereas angled rays do, whether they are reflected or refracted. All perpendicular or right-angled light passes right through, and parallel light not as much. Let's split light into vertical and horizontal components and model refraction, remembering that some substances absorb less light. On to diffraction. You don't need to think too much about why exactly it happens, since it is just waves bending around a gap. You may be wondering why waves diffract more around a narrow gap than a larger one. For the same wave at the same speed, if a gap is smaller, less of the wave is packed into the gap at a time, so there is less interference amongst itself, which is what happens when the wave meets itself out of sync and cancelling happens. In a larger gap, there is more interference and cancelling, so the wave spreads out less. You'll also often find that waves can be partially reflected and partially refracted. This is why you see your reflection above the water surface, but the hungry crocodile beneath the water can see you. The Doppler effect is literally what you hear when the police are after you but don't find you, and go right past you, and you hear it get higher and lower as it moves towards you and away from you, and not just louder and quieter. This is because as the source moves closer to you, the distance between your ears and the source decreases, so the wavelength decreases and the frequency increases, which is why it sounds high-pitched and hurts my ears when it is close to you.